So if we know that this equation now represents the number of neutrons n0, and it's 0 because the neutrons give no charge to the atom, equals the mass, and that's not the average atomic mass on the periodic table, but the mass of the isotope minus the number of protons, P positive, because the protons have a positive charge, we can now calculate, based on our isotope notation, the number of neutrons. For example, if I have neon 20, my mass is 20, minus the number of protons is 10, because I know that the atomic number is equal to the number of protons. So I will have 10 neutrons. For, that's a little bit off to the side. So for neon 21, it will be 21 minus 10, a mass of 21, mass of the isotope is 21 minus 10 protons. Atomic number is equal to the number of protons. So I have 11 neutrons. And likewise for neon 22, I have a mass of the isotope of 22 minus 10 protons, giving me 12 neutrons. So at this point, we can go back to the chart that we were using to analyze the information on the periodic table. And we can also use this chart to see how we can analyze the information that's given in isotope notation. For example, beforehand, we were just getting the atomic number off of the periodic table for Ti, and we found on the periodic table that Ti has an atomic number of 22. So that's how we were able to fill out previously that the atomic number was 22. We know that the number of protons is equal to the atomic number because an element is defined by its number of protons. So we had 22 protons for Ti. And we also know that in a neutral atom, you're going to have the same number of electrons that you do protons to balance out the charges. So that was just looking at the periodic table and analyzing the information that way. Now that we know more about isotope notation, we can get the same information out of our isotope notation. If I have the isotope notation including the atomic number, then automatically I can see, without even looking at the periodic table, of course, if this atomic number weren't there, then I would have to look at the periodic table. But because it's there, I can automatically see, oh, my smaller number is 22, so that's the atomic number. And therefore, the protons is also going to be 22. There's no charge here on this isotope. Therefore, the number of electrons will be equal to the protons. Now, mass number. The larger number is going to be the mass number, so that's 48. And we know now that the neutrons are equal to the mass minus the number of protons. So 48 minus 22, or 48, the mass number minus the atomic number for the isotope, will just be 26. And to check ourselves, of course, we know that the neutrons plus the protons have to equal the mass. So 26 plus 22 is 48. If we do the same for titanium 47, our mass number for titanium 47 is 47. 47 minus 22 is going to be 25, because the mass of the isotope minus the protons gives you the number of neutrons. Double check ourselves again. Neutrons plus protons gives you the mass. 25 plus 22 equals 47. We'll do one more. Silver 108. So silver always has an atomic number of 47. Therefore, its number of protons will be 47. This is a neutral isotope species, so the number of protons and electrons are equal. So the number of electrons is 47. It's silver 108, so the mass number will be 108. And then the neutrons is simply found by subtracting the mass minus the protons, the mass of the isotope minus the number of protons. So 108 minus 47 gives you 61. To double check yourself, so neutrons plus the protons, the number of neutrons plus the number of protons will give you the mass number. So 61 plus 47 is 108. And in this way, we can be able to continue to analyze all of the isotopes that are listed on this chart, and therefore analyze the information provided to us in this form of isotope notation.